Is an operating systems question based on process scheduling. We have been given 4 options, and out of them we need to identify which of them is or are correct. So it is an MSQ type question. Option A is saying that turnaround time includes waiting time. Now, how do we calculate the turnaround time? We make that table in which we have the arrival time, burst time, completion time, which we derive from the Gantt chart, and then after that we have a column for turnaround time, which we calculate as completion time minus arrival time. So basically this turnaround time includes both the burst time of a process as well as for how long has it waited. For example, a process entered at, let's say, time t equal to 1 unit, but it got scheduled at time t equal to 4 units. So from unit 1 to unit 4, it waited for 3 units of time. So that is its waiting time, and then it completed its execution at t equal to 6 units. So from 4 to 6, 2 units, it had its burst time. So this turnaround time will be the sum of both waiting time as well as burst time, because we will be calculating it as 6 minus 1, which means it's completion time minus arrival time. So 6 minus 1 is 5, and as you can see, waiting time plus burst time, 3 plus 2 is also equal to 5. So this turnaround time includes waiting time as well. So the statement is correct. Next one is saying goal is to maximize CPU utilization and minimize the throughput. The goal is actually to maximize both CPU utilization as well as throughput, because throughput is how we are actually utilizing the CPU. This throughput is in similar lines as of utilization. So both are to be maximized, and instead we have to minimize the turnaround time, the waiting time of processes, because if we decrease the waiting time, then turnaround time will also decrease. So this one is incorrect. C is saying that round robin policy can be used even when the CPU time required by each of the processes is not known a priori. A priori means beforehand. If we do not know the burst time of the processes beforehand, can we use the round robin algorithm? Yes, we definitely can use, and it is actually more suitable in these situations itself, because what do we do in round robin policy? There is a fixed time quantum for which we execute each process one by one until it completes. So even if we don't know, and we don't actually need to know even what is its burst time, because we will keep executing it in different slices of time quantum each, and when it expires, then we will call it off. So round robin can be used. The statement is correct. The last one is implementing preemptive scheduling needs hardware support. What is preemptive scheduling? It is a kind of CPU scheduling in which, while one process is executing and another high priority process arrives, or if its time quantum expires, then in those situations we need to bring that process out of CPU execution and put another process at its place. So we are basically needing to swap two processes with each other. We need to preempt one and put another in place of that. So this action requires the support of hardware. Hence, implementation of preemptive scheduling requires some hardware support. So statement D is also correct. So we got A, C and D as the answer.